Welcome, everybody, to our talk today, Building a Path Forward with Stefan Sommer. I'm Frankie Reamer. I'm a board member and founding member, along with Stefan, of Northern Arizona Climate Change Alliance, and I'm going to be the moderator for today's session. Again, thanks for joining us on your Saturday. Today's event is part of a longer series, Climate Talks for Everyone, and it's co-sponsored by Fridays for Future USA, Climate Elders Action Arizona, and Northern Arizona Climate Change Alliance. We welcome other interested groups to join us in sponsoring this series and other series of educational talks on climate. In organizing the session today, we're asking folks to stay muted, just so we can all hear the speaker. And we're also going to start with asking you to post your questions in the chat as we go along, and then we'll see once Dr. Sommer's presentation is done, we'll see what size looks like and see if we can have a conversation or if we want to continue to rely on the chat. So thank you. This is my main job. I'm very excited to introduce my colleague, Dr. Stefan Sommer, who's going to talk to us today about what the next steps are in our path moving forward, building and moving forward. Dr. Sommer is a science communicator, film producer, author, and public speaker, and again, a founding board member and speaker for Northern Arizona Climate Change Alliance. He's an affiliate in Northern Arizona University's Department of Biological Sciences and the Center for Adaptable Western Landscapes. And he brings expertise in community ecology, sustainability, climate change, and education outreach. Dr. Sommer writes for the Arizona Daily Sun as author and editor of the column Spotlight on Climate, and he's served as executive producer of 4 award-winning PBS documentaries on biodiversity and habitat conservation. So, Dr. Sommer, I will give the floor, or whatever we have here in Zoom, over to you.
Well, thank you very much, Dr. Reamer, and welcome everybody. Thank you all for coming out on a Saturday. About 15 minutes ago, we were having thunder and lightning in the distance, but now we have blue skies. So, so today we're going to talk a little bit. Last time we talked about climate change, the basics, and what science can tell us about it. Today, I will try to address some of the things that we can do about climate change. It's hard to cover everything in such a short amount of time, but we will cover as much as we can. So let me pull up my PowerPoint here. Okay. Can everyone see the screen okay? I guess I shouldn't be asking. Francis, is it good?
Yes.
Very good. Okay.
Yes.
So we talked last time about the effects of climate change, and this, of course, is one of the many kinds of outcomes we're seeing as a result of climate change. Lots of flooding, drought, all sorts of climate extremes as we put more heat energy into our atmosphere and on the land surfaces and the ocean surfaces. So we're seeing all of these negative outcomes on a global level now, and it's headlines every day. So how do we build a path forward? You know, do we work our way out of this in a technological way, as this picture would suggest? And this, perhaps, this is a city designed for China by Arco Santi, which is a sustainable community building group just to the south of us here in Flagstaff. And they have this lean linear city design, which has a very low carbon footprint, a very low landscape footprint. And so we'll talk briefly about that kind of thing a little bit further on. But first of all, just to recapitulate, what have we done to CO2 concentrations? And I'm sure y'all have seen this, but since 1960 alone, we have increased our overall concentration of carbon dioxide in the atmosphere very dramatically. Before the Industrial Revolution, we were at about 280 parts per million CO2 in our atmosphere. And as of today, we are at 419 parts per million. And of course, y'all can see this little red squiggle. So the black line is the annual average. But the red squiggle, what that is seasonal variation. So every year we go through summer and winter, and we're all carbon-based organisms. So we have life has a big effect on CO2 concentration in the atmosphere. During the summer months, there's relatively more photosynthesis, and photosynthesis uses CO2 as a raw material, combines it with sunlight energy to produce chemical energy that powers our lives. When we take in some of that chemical energy as food and burn it physiologically, we respirate, we release it back into the atmosphere as CO2. So when we've got more photosynthesis during the summer, that would be during the trough in this little red oscillation. In winter, when there's relatively more respiration, more CO2 being released by life than is being absorbed by life, that's the peaks in the little red oscillation. So winter, summer, winter, summer. And this is from, as it's measured out on Mauna Loa in the middle of the Pacific. So it's away from industrial centers. By the time the atmosphere has reached there, it's a good mixture of what's going on in the northern hemisphere, because there's relatively little exchange between the northern hemisphere atmosphere and the southern hemisphere atmosphere across the equator. There's some exchange certainly, but relatively little. And that's why the red oscillation shows up as these summer and winter cycles, because it's reflecting what's going on primarily in the northern hemisphere's atmosphere. So to me as a biologist, the magnitude of that red oscillation is huge. That's the annual change of all the effects of photosynthesis and respiration caused by all living organisms in the entire northern hemisphere. So that's a huge annual change in CO2 concentration. And then if you look at the magnitude of what we've done just since 1960, it kind of puts it in perspective. We have dramatically changed greenhouse gas concentration, this particular greenhouse gas concentration, in very short period of time. And we know from last time, in both of these graphs, the black line is the actual temperature record from about 1900 up to about 2005. And all the little red squiggles are different runs of a model that climate scientists put together, where they included all of the natural forcing factors, what they call changes in the Earth's orbit around the sun, all the Milankovitch cycles, major volcanic eruptions, and other natural forcing factors, along with the anthropogenic, that is the human-caused forcing factors, which are things like changing the concentration of greenhouse gases like CO2 and methane and nitrous oxide. So in this model up here, all of those different factors, human-caused and natural, are included in the model. And the model tracks reality over the last 105 years pretty closely. So that's one way to test your model. Can it predict what you know to have already occurred? And in this case, the modelers concluded, yes, this is probably a good model for Earth's average temperature. Then they ran the model again, but they took all the anthropogenic forcing factors. And it's not just change in greenhouse gases, it's also changes in the reflectivity of the Earth's surface. So when we convert a natural habitat into a parking lot, it changes the albedo, that is the reflectivity of that surface. So those are some of the primary ways in which human beings are affecting the Earth's average temperature. So you take those factors out, and here's the output of the model, suggesting that since about 1960, it's primarily the changes that human beings have caused to the atmosphere and the Earth's surface that are causing this change. If without those factors, the Earth's temperature would be down here somewhere in this blue line. So this is really the smoking gun that says, yes, human activities are the cause of current climate change. We went through that in more detail last time, and that was recorded. If you all want to see, if you all missed the last presentation and want to see it, it is available on the NASCA.org website. Okay, and this is a graph from the IPCC special report in 2018. The IPCC stands for Intergovernmental Panel on Climate Change, and it's a body of scientists from around the world who review the scientific research literature and report to the world what that literature is telling us. In this case, the y-axis is actually temperature change. How much have human activities changed the Earth's average temperature? And so already back in 1960, we had raised the Earth's average temperature by somewhere around 0.3 degrees centigrade degrees. By 2017, when this graph was made, we had raised the Earth's average temperature by a little over 1 degree centigrade. And at that time, we were projected to reach 1.5 degrees centigrade warming in about 2040. And the details of this, of course, are to what extent do we rein in our emissions, and to what extent do we change human behavior to affect when we will reach 1.5 degrees centigrade warming. Now, to reach that, back in 2018, they were telling us this. Here, in this case, this is actually CO2 emissions on the y-axis. And by 2017, we were producing more than 40 gigatons of CO2. We were releasing more than 40 gigatons of CO2 into the atmosphere per year. To avoid reaching 1.5 degrees centigrade warming, they told us that we would need to dramatically reduce our emissions. If we wanted to reach net zero either by 2055 or 2040, we could change the overall amount of CO2 we're putting into the atmosphere. And this is the overall amount of CO2. So since the Industrial Revolution, we have currently put over, currently had put over 2,500 gigatons of CO2 into the atmosphere. When we reach 3,000 gigatons of CO2, if we continue with our emissions along this gray line, then we will have put 3,000 gigatons of CO2 into the atmosphere. If we rein in our emissions like this, we will have put just over 2,500 gigatons of CO2 into our atmosphere. We are projected to reach about 1.5 degrees centigrade warming when we have put 2,900 gigatons of CO2 into the atmosphere. And the important part of this graph, too, is to understand that once we put that CO2 into the atmosphere, it's not easy to take it back out. And it takes a long time and all sorts of processes. We'll talk about some of those. So we want to rein in our emissions, something like this. What do y'all think? Can we do this? Well, the answer is clearly yes. There are many studies that have shown that we can do this. The question is, will we do this? And everything currently suggests that we will not. We have not been able to rein in our emissions. Instead, our emissions continue to increase. So if we reach 1.5 degrees centigrade warming at 2,900 gigatons of CO2 into the atmosphere, and this was calculated in 2020, when we were at 2,400 gigatons, suggesting that we only had 500 gigatons remaining that we could put into the atmosphere before reaching 1.5 degrees centigrade. In 2020, the estimate was that we were releasing 59 gigatons of CO2 into the atmosphere per year. And I should say CO2 equivalent. So this includes the other greenhouse gases like methane, which is a much stronger greenhouse gas, nitrous oxide, and those all converted into CO2 equivalents, 59 gigatons per year. So if you just do the math, the simple math on this, at 59 gigatons per year, how much time do we have left before we reach 1.5? Well, that's about just a little over 8 years. And remember, we're in 2020 for these numbers, meaning that we would reach 1.5 degrees centigrade warming by 2028. So this is from the IPCC report of 2022. You can see that the projections had sped up dramatically. Back in 2018, they were saying we would reach 1.5 in 2040. And last year, end of last year, they were saying we're going to reach it in 2028. And the reality is we've been in La Nina conditions for the last 3 years. And when the world is in La Nina conditions, temperature tends to be a little bit lower. When we go into El Nino, it raises the global average temperature by about 0.2 centigrade degrees. So if we've already raised the Earth's temperature by about 1.3 centigrade degrees, and we go into El Nino now, it could be that we'll reach 1.5 degrees centigrade warming next year. So this is just a graph to illustrate this concept that we've got only so and so much remaining CO2 to put into the atmosphere. And this graph was actually put together by a rocket scientist, Patty Michelle Schaefer, who's a NASCA member down in Prescott. And what she's saying is, okay, if we start reining in our emissions like this, you know, this is the remaining amount. If we're in 2020, that's that remaining, she was saying in her calculation, 700 gigatons. And if we don't rein in immediately, that just means that our reining in has to get steeper in the future, meaning that our kids will have to rein in their emissions more and more the longer we put off reining in emissions now, right? So if we put this off further, then we've got to drop steeper and further to avoid reaching 1.5 degrees centigrade. Now, that was the goal back in 2018. Now we know we're about at 1.5 degrees centigrade already. So still, we need to rein in our emissions so that we don't continue to go further. So the kids know about this, and they're getting unhappy about it. This is a protest in Norway in 2014, and I want you to watch all the faces and see how the level of concern is shifting here across time. This is 400,000 folks who were marching in Manhattan, also in 2014. 15,000 in Australia in 2018. 35,000 in Belgium in 2019. 1.6 million at the Global Fridays for Future March in 2019. 7.6 million marched at the Global Climate Strike in 2019. So what we've done so far has been very destructive. We're already seeing that destruction happen on a global basis, as we talked about last time. Our kids know it. They're angry about it, and they want us to do something. So what are we going to do? So far, if you see this graph, this is one way to depict rising temperatures from 1850 to 2016. Each turn around the circle is a year. These are the months. And you can see two things in this. One, the average temperature of the Earth keeps increasing. Two, it keeps increasing faster and faster. So we've seen these kinds of headlines. This is a headline from 2019. We've put more heat energy into our atmosphere, the oceans, land surfaces. What do we expect? We expect more extremes of all kind, more energy in the system, more swings, more drought, more floods, more heat. Some of the scariest projections about this was published in the Lancet. It's a medical journal back in 2016. And they were looking at if agricultural productivity lowers because of this climate change in the way that is projected to decrease, how will that affect human diet? And based on that, they said, okay, well, there'll be less meat in people's diet. That will actually reduce mortality. But there will also be less fruits and vegetables. And they, year after year, all that projection was made. And their median projection for year 2050 is that they expect 529,000 deaths per year due to solely diet change causes. This doesn't include the flooding and the extreme storms and so forth. It's just that many deaths because human diet has shifted. And the range of outcomes in their models went over 1 billion folks per year. But the median projection was 529,000 deaths per year by the year 2050. So what can we do? What do we need to do? And I just want to remind everybody that emissions are additive. When we run our grill in the backyard, yeah, that's a small amount of added CO2, but every bit we emit matters because it's all additive, and what we emit now will continue to affect the Earth for some time. So we need to reduce our carbon emissions at the individual level and the collective level. Certainly the largest footprint that we have connection with is what's our whole society doing. And that has to do with the technology we're using. It has to do with individual practice, our consumption rates, all sorts of different things go into that collective carbon footprint. But also what we do as individuals does matter. Every bit we emit matters. And so we'll talk a little bit about population and how that affects this, power generation, transportation, land use, and a few other things. So this is just a little bit of a preamble to show you where we're heading. The Northern Arizona Climate Change Alliance is aware of these problems. And so we have, here in Flagstaff, we have 14 active climate action teams who are working with the city and working with the community to try to lower carbon footprints. We've got about and climate action team acronym is CAT. So we refer to these groups as CATs. We've got the Bike Cat, which is now in the process of changing their name to the Ped and Pedal Cat, because they want to create a culture of walking and biking to get folks out of their combustion vehicles. The Clean Health Cat is dealing with the proposal for $1 billion development on the edge of town, which we're fighting. We've got the Climate Educators Cat, which puts together things like this presentation. Our Fleet Electrification Now climate action team. And there are climate action teams like that in Sedona, Cottonwood Verde Valley, and Prescott as well. They are trying to push the city of Flagstaff, Coconino County, FUSD, the Flagstaff Unified School District, NAU, Northern Arizona University, and our bus fleet, Mountain Line Bus, to all electrify their fleets more rapidly than they currently are doing. So we collect signatures on petitions so we can say, yes, City Council, this many of your constituents are very concerned about this. You need to act now. So we work on this in many different ways, and we won't go into all the details of that. So over the years, these climate action teams have helped to push the city to do things like develop and pass a climate action and adaptation plan, develop and pass a carbon mitigation plan, and so forth. And we'll talk about those here in just a second. So I just want to go through a few things that have been happening globally and locally. So France said that it would ban the sale of petrol and diesel cars by 2040. This is a good step in the right direction. Is it enough? No. Is it soon enough? No. The European Investment Bank announced back in 2019 that it will stop lending to fossil fuel projects. This is a wonderful thing. Is it enough? No. The European Union called for net zero by 2050. They did this in 2018. It's a wonderful thing. It's very good to start reining in our emissions. Is it enough? No. In 2019, the European Union also ratified the Green New Deal for Europe, with the abstention of Poland, who wanted to continue to burn coal well beyond 2050. In any case, there are always conversations about this, and to do collective action, we need to bring everybody on board for these kinds of decisions. So like I was saying, back in 2018, Flagstaff City Council passed the Climate Action and Adaptation Plan, which set the goal to be net zero by 2030. And that was put into our regional plan in 2020 already. And the idea was for the city itself, the municipality, to be net zero by 2025, and for the entire city, all the private and business and municipal uses, to be net zero by 2030. Our regional plan states that that's the city's goal, and that any new development proposals need to help the city meet that goal. Also in 2020, our state utility, APS, Arizona Public Service, announced that they're going to be zero carbon by 2050. This is a good thing. It's a good step in the right direction. Is it enough? Again, it's not. So we need to keep on encouraging all of these collective bodies and businesses to be even better. Sedona has followed suit in many ways. So they ratified their climate action plan in 2021. And Dr. Reamer has been heavily involved in that kind of thing. But what we're realizing here in Flagstaff is that even though our climate action and adaptation plan and carbon mitigation plan and all those things were passed, it's easier to pass them than to implement them. And so our current city council has failed to implement our regional plan in several recent decisions. One being that they would not divest the city's money, our money, from the dirty bank, Wells Fargo. They decided to stay with it, even though there was a climate action team, Fossil Free Arizona, who was pushing them hard to go to a cleaner bank. With this billion-dollar development proposal on the edge of town, the city council, even though the Planning and Zoning Commission listened to our lobbying and recommended no on the rezoning required and the development plan itself, and passed that recommendation to city council, on June 6th, city council approved the rezoning and the development plan. So we've gotten a referendum onto the ballot. The developers sued us twice and lost in court both times. So it will be on the ballot, and now we're in a major campaign because the vote will be finalized on November 7th. So we need to push our governmental bodies to put the right plans in place, and then we need to continue to push to get them to implement those plans. Same things going on in Sedona. They've got a climate action plan in hand, now pushing for further and more complete implementation. Cottonwood is still in the earlier stages. They're encouraging their city to create a climate plan. Prescott is now encouraging the city council to pursue pursue climate risk assessments, which are sort of the first step in developing a climate plan. So in 2021, Flagstaff City Council passed the carbon neutrality plan. They also recently passed a transportation master plan, which calls for multimodal transportation. So they are supposed to now implement greater bike safety and more clean public transportation and all those sorts of things. So our bicycle cat, our ped and pedal cat, recently, that is last Tuesday, got the city council to say that they would change the settings on our walk signals at intersections. So one thing that happens is that right now, our walk signals are set to stay in this position, stop, don't go, until you push the button to go. So for a biker, even though the light is green, they have to stop, push the button, and then go. The other thing is if they just go across, it's usually most of the bike accidents, bike and combustion vehicle accidents, are when cars are turning right at an intersection. And they do that because they don't see the bike, they're not looking in their rear view mirror closely enough. And so we want a safe pedestrian interval as well. So the walk signal should change from stop to go 3 seconds before the light turns green for the vehicles. That allows people to step off the curb and be seen by the vehicle before it turns. So the city council approved both of those things, and they're going to put it into serious consideration within the city mechanics. So those are a lot of the things that sort of happen at the collective level. It's always an ongoing effort to push our city councils, our state legislatures, our national Congress to do the right thing. Sometimes it's easier at the local level than it is at the national level. So what can we do? What, as individuals, how should we be orienting ourselves towards carbon footprint? Well, we can upgrade our light bulbs to reduce our footprint by 1/10 of a ton per year. Recycle 2/10 of a ton per year. Hang dry clothes 2/10 of a ton. Wash clothes in cold water 1/4 of a ton. Replace a gas car with a hybrid. That reduces your footprint by 1/2 a ton. Eat a plant-based diet. Switch to an electric car or be car-free. That's 1.5 tons. Buy green energy. Avoid one transatlantic flight, 1.6 tons. Live completely car-free, not just buy an electric car, but live totally car-free, 2.4 tons. But what's the one thing you can do in your life that has the biggest effect on reducing your carbon footprint? Have one fewer child. That reduces net 58.6 tons of CO2 per year. So population growth has a big effect on this. It's not just our consumption patterns and so forth, but it's also how many of us are following this or that consumption pattern. So we already talked about this: hang laundry to dry, recycle, wash clothes on cold, drive a hybrid vehicle is a step in the right direction. It's not enough, but a step in the right direction. Switch to a vegetarian diet. Animal husbandry has a large carbon footprint. Certainly not as much as our transportation, but still a significant carbon footprint. Buy green energy. We'll talk about that in some detail. Stop flying. Another big aspect. Don't use a car and have one less child. Or, well, in whatever way you can, do not add as much to our population growth. Here's overall global population growth. The green is the actual numbers of people, and we can expect those to continue to increase up to the year 2100 and beyond, even though our percentage growth has been dropping since about 1968. We reached a peak of 2.1% growth in 1968, and it's been dropping since then. But because we have young people who are pre-reproductive age in that population, that growth continues on for some time, even though our percentage growth rate declines. Okay, how do we reduce population growth rate? Well, there's educate women globally. When I make this presentation in person, usually the women in the room say, "What?" And I said, well, we tried to educate the men. It just didn't work. So, and what this really refers to is not educating them to be smarter about having babies per se, but giving them the economic security through education that they need to feel safe for the future without having a large number of kids. So empower women through educational opportunities, through small business loans, secure and universal health care, and job retraining as markets shift. And if we're talking about the kinds of societal shifts that we need to reduce our emissions, it's going to require all sorts of societal shifts, including job training. So what do you do for the fella who's been spending his life working on combustion engines? Well, you got to retrain him to work on electric engines or, you know, some other new energy mode production so that he can continue to support himself and his family, he or she. So the IPCC report from 2018 also made some projections as to how we can reduce our carbon footprint by reducing emissions. And they've got 4 different scenarios here. Each of these scenarios is about reducing fossil fuel and industry emissions, reduced consumption, reduced agricultural emissions of nitrous oxide and methane, and then also to change our land use practices and energy infrastructure. So the part in brown on these graphs is from agriculture, forestry, and other land use shifts. BECCS refers to bioenergy and carbon capture technologies to remove energy from the atmosphere. And so they put together 4 scenarios for reaching net zero. And there are a lot of details to each of those. And we'll just talk a little bit about what are some of those components that would allow us to reduce our carbon footprint. So one aspect of land use, if you think about where is carbon on the earth? Well, a lot of it is in living systems, but a good bit more of it is in the decayed carbonaceous material that's in soil. So soil is a huge repository of a lot of carbon. When we till soil, what we're doing is we're mixing in oxygen to that soil, and that greatly speeds up the decomposition of the carbon that's in there. And there's a fair amount of carbon that's released as a result of tilling the soil. So we need to change our agricultural practices to more what we used to do, and what they still do in some parts of Europe, is putting all the extra non-consumable parts of agricultural yield back into the soil. So rather than just removing carbon from soil, we need to begin putting more carbon back into the soil. So you can do that through what's called regenerative agriculture and permaculture type of processes and reduced tillage, although really we need to go more towards permaculture so that we continue to put carbon back into the soil rather than removing it. So these are just some pictures of ways to put more carbon back into the soil and reduce the rate at which we're releasing it from soil. is just an illustration of some of the kinds of carbon that can be stored in soil. And different plant species, of course, have different degrees of putting carbon back into the soil. And it's not just the plant growth and the roots and so forth, but also our agricultural and land use practices that have a big impact on how much carbon stays in the soil. How much potential does soil sequestration of carbon have? Well, this was in a presentation by a United Nations expert, soil scientist, and he was saying that the technical potential for putting carbon back into soil was about 1.3 gigatons carbon equivalent per year. So yes, we need to reverse the release of carbon from soil, and it has the potential to actually take more carbon out of the atmosphere and keep it stored in the soil at the rate of about 1.3 gigatons per year by this expert's estimation. How do we do that? Well, we get away from this kind of agriculture and go more towards, using horse manure and cow manure and other types of fertilizers rather than additions of nitrogen fertilizers. We don't transport our food as far, so we go to farmers markets where you can meet the producer of your food and get the details. Did they use pesticides? How did they raise that food? Are they putting more carbon back into the soil than they're removing from it? And many of the farmers market farmers might not know that part, but they'll know for sure what kinds of pesticides they did or didn't use. And so it's really important to connect with your food producers, and you get much better food that's much more nutritious at the same time. So farmers markets have many positive effects on the outcome of how we raise our food. This is a picture from the Sedona Community Farmers Market. There are programs of all sorts that are trying to regrow forests, and in some cases grow forests in places where they didn't occur before. Reforestation is the name for regrowth, and afforestation is the name for putting forests, growing forests in new locations. Overall, our global forests contain about 600 billion tons of carbon. That's about 15 years worth of CO2 emissions, as calculated back in 2015. Now our emissions have grown a good bit, so probably less than 15 years at this point. And the good news in all of this is that some countries are now beginning to regrow their forests. And through reforestation and afforestation, they're actually increasing the amount of forest cover in countries like China and the United States, less so in places in South America, Australia, Indonesia, and Africa. Well, what's the potential for getting forests to actually store carbon? If we calculate it just as carbon, these are the numbers up here, but if we calculate it as CO2 or CO2 equivalents, forests have the potential to absorb about 8.8 gigatons of CO2 per year. And in the process of their own living, they also release 4.8 gigatons of CO2 per year because they got to power their own lives, and there are lots of other forest processes that release carbon. So net absorption, the potential there is for forests to absorb about 4 gigatons of CO2 per year. Carbon dioxide removal is the process of capturing industrial CO2 before it's released to the atmosphere and pumping it underground. I'm a little bit skeptical about the pumping it underground part, although there are some cases in which that can actually work. And we'll talk about those in a little bit of detail. There are other ways that you can capture that CO2 from the waste stream from industry. And again, afforestation and reforestation are good ways to capture some CO2. At the moment, The Earth's forests have about the potential of capturing about 4 gigatons CO2 per year. One thing you can do with industrial waste streams is bubble them through vats of algae. The algae photosynthesize, they use the CO2 in that waste from the industry, and they release oxygen. And you can use that algae to produce oil that can become biofuel. So there's some potential in this to take some of that CO2. The chemical capture of CO2 from industrial waste streams is to use alkylamines, basically acid gas removal of that CO2 from the waste stream if you're not using algae or something biological. That has some potential and it's being done in some places. One brilliant idea is to take that waste CO2, pump it in the subsurface to help push gas and oil out for further fossil fuel development and consumption. Seems to me that's not really the best way to use that CO2. There's just a diagram of that acid gas removal. And there are some plants in this particular one, the Schwarze Pumpe is in Germany, but this is not being used broadly. An interesting proposal for removing CO2 from the atmosphere is put together by companies like Climeworks in Switzerland. And they've been able to apply this technology in Iceland. And it really works there in the sense that they can use waste heat from the geothermal energy production in Iceland to make this go without burning fossil fuels to make it all happen. And the way it works basically is they pump air past these amine filters, which absorb the CO2. With the waste heat from geothermal, they can then remove the CO2 from those filters and pump it into the subsurface where it crystallizes, deposits on basaltic type of rock. And this is all good in only when you're using that waste heat energy, first of all, to pump atmospheric gases past those filters, and then remove it from the filters and pump it below ground. If you're using fossil fuels to do those things, the net gain is very little. This is just one of the larger installations of Climeworks technology being tested, in this case, in Switzerland. And the technology works. But think about this. How big is our atmosphere? Pretty big. How distributed is the CO2 and other greenhouse gases that we put into it? Pretty distributed. Can we pump our entire atmosphere past these kinds of amine filters? I think largely the answer is no. So here's an evaluation of all the various different kinds of carbon capture and sequestration techniques. It's estimated that we need to reduce atmospheric carbon by about 20, carbon dioxide by about 20 gigatons per year, every year from the year 2050 to 2100, if we want to reverse some of the amount of CO2 we put into the atmosphere. Like we were talking about, reforestation and afforestation has the potential, and this is from a Scientific American summary article put together by Conniff in 2019. His estimate was that forests could remove about 3.6 gigatons per year, a little bit different than the estimate I gave you a minute ago of 4 gigatons per year, as calculated back in 2015. Bioenergy, carbon capture and storage. This is a question for me. So if we capture some of that carbon coming from the waste stream in industry, and then we burn it as a source of energy, the oil produced by it, you know, how much real benefit is? Well, in this article, they were estimating that they could take about 4 gigatons of CO2 out of the atmosphere per year with this. I'm not entirely convinced. Biochar has been another proposal. And the idea is you, in essence, burn biological material at very high temperatures to produce charcoal. And then you take that charcoal and put it back into soil as a one way to store more carbon in soil. So I think it has a little bit of a potential there if we in fact put that back into agricultural soils. But it all depends on what kind of heat source you use to create that charcoal. If you're burning a bunch of fossil fuels to do it, then the net benefit is zero. Maybe if you're using solar energy or some other heat source, then possibly. In any case, they were estimating that that could result in the storage of about 2 gigatons per year. Enhanced weathering is another proposed thing. And the idea there is to take some of that basaltic type of rock that is being used in Iceland to store crystallized CO2. You can pulverize that sort of rock, spread it in agricultural fields, and it also will attach CO2 to it. It has potential for a larger number of tons of CO2 stored per year, 70 gigatons, but it's a very expensive process. First of all, you got to mine that rock, then you've got to pulverize it, then you've got to transport it and spread it. So I'm thinking, the costs of that are probably going to make it prohibitive in terms of really being able to take any CO2 out of the atmosphere. Direct air capture is what I was talking about with Climeworks and related technologies. That has the potential for taking about 5 gigatons of CO2 out of the atmosphere per year. It costs a lot of money. And can we really pump all of our atmosphere through these kinds of filters? I'm thinking probably not. Ocean fertilization. The idea here is that the open ocean, the main limiting nutrient is iron. We know that we can cause large algal blooms by putting iron filings across large areas of the ocean. But what are the downstream consequences of that? And does it really remove carbon? Because what happens then to the algal bloom? I'm thinking no. This would be such a huge disruptive effect on all of the ocean's ecosystems. The only way that this really works is if those algae that we stimulate to grow die and sink to the bottom of the ocean. But then what happens to them when they sink to the bottom of the ocean? Well, the bottom of the ocean is low in oxygen. If that material gets there, first of all, we don't know that, and then starts to decompose under anaerobic conditions, what it will release is methane and not CO2. So I think the net effect of this hasn't been fully tested, but what we've seen in terms of the research done on this so far suggests that instead we would get methane production. And so I'm thinking this not only would disrupt ocean ecosystems, but would make the greenhouse gases released even worse. How about soil carbon sequestration? Well, in this article, they were estimating that that has the potential for about 15 gigatons of sequestration per year. If you add the biochar and all these other things, that's different than what the FAO, United Nations expert, was saying in his presentation. But if we can make this work, I think it probably has less disruptive effect on other ecosystems. And so if you take that 3.6 gigatons from afforestation and reforestation, 15 gigatons from soil carbon sequestration, that gives us about 18.6 gigatons per year, which is close to the 20 gigatons per year we need. Anyway, so this is an estimation by CONIF from 2019. I'd like us to get back to some of the IPCC projections for a moment. When we hit 1.5 degrees centigrade warming, this is from the IPCC special report of 2018, they were estimating that the cost of climate disasters, storms, floods, drought, would reach about $54 trillion per year. If we let things go to 2 degrees centigrade warming, they projected then that we would reach about $69 trillion per year in damages from climate effects. Do these kinds of damages fit into the global economy? Well, the global gross domestic product in 2021 was 149 trillion. Can we fit 54 trillion into that? I think the answer is no. I think clearly the answer is no. But I'm going to talk a little for a moment about a project put together by Jacobson and colleagues at Stanford University and the Max Planck Institute in Germany and so forth. And they were saying that if we take known technology, wind, photovoltaic, and so forth, and use it and implement it to reach net zero by 2050. Remember, they're doing this study. Well, don't remember. I haven't told you yet. This study was done in 2017. So at that time, the goal was still to be net zero by 2050. They said that we could do that at a cost of about 1.6 to 3.8 trillion per year. Investment in renewable technologies to get away from fossil fuels. So does this fit into a global economy of 149 trillion? I think the answer is yes. If we were to do this, this would easily fit into the global economy, whereas these damages would not. So that's just a projection of the global gross domestic product. And I think 1.6 to 3.8 trillion dollars fits well into that size of a global economy. This is that Jacobson et al. Study. They called the output of their study the Solutions Project. If anybody would like a copy of that, I'm happy to share it. It's was done in 2017, so it's certainly out of date by now in terms of the projected goals that we need. But they pointed out that this would, if we did this, it would allow us to get 80% net zero by 2030 and 100% net zero by 2050. One thing they point out is that if we stop mining and distributing and processing fossil fuels, that in and of itself will reduce our overall carbon footprint by 12.6%. There will also be a lower loss of life from air pollution. And we would be able to avoid, they were saying at the time, 1.5 degrees centigrade global warming. We know that's no longer true. But here's what they're saying, basically, is that we would be able to reduce our power demand. For one thing, electric engines are much more efficient than combustion engines, and so that reduces our overall need, our consumptive need by 23%. And end-use efficiency beyond just that business as usual would be an additional 6.9%. The 12.6% that I already mentioned from less energy needed to mine, process, and distribute fossil fuels. And then we would replace fossil fuels in their plan with onshore wind, offshore wind power, utility level photovoltaic solar, and concentrated solar power, and then residential photovoltaic and commercial government building photovoltaic power would be a big part of it. And then they're not really saying that we should increase hydropower or geothermal, because those also have environmental impacts of various sorts, but that we should continue to using the hydropower and geothermal that we have. So that's their plan in a nutshell. They projected out exactly how many wind power plants and how many photovoltaic plants are needed by each of the 200 some countries that they did this study on. And they also at the time in 2017 said, okay, which countries are already kind of there? Well, at the time, Tajikistan was further ahead than most at 76% clean energy. Paraguay was up there, Norway, Sweden, and China was down around 5.8% renewable energy back in 2017, and the US at only 4.2%. So we've got a long ways to go. these are the projections on how many offshore, onshore wind power plants we need, how much more roof photovoltaic we need, how much more tidal power in those countries that have that potential, and so forth. So they projected this for all the different countries, and this is the summary table of how much more we need in all of those. The good news is that we are putting in a lot of that kind of renewable energy. So right now, as we speak, out at Chevelon Butte, which is just outside of Winslow, Arizona, they're putting in a wind power plant that's a 477 megawatt wind power plant. And so that's going to increase the percentage of clean energy in our grid here in northern Arizona significantly. Overall, we already have the Dry Lake Hills wind power plant, which produces 127 megawatts of clean electricity. The Perrin Ranch wind power plant that produces 99 megawatts of clean electricity. As we speak, Babbitt Ranches is putting in 241 megawatts, that's 161 megawatts of wind power and about 80 megawatts of photovoltaic power just north of the peaks. This is the Chevelon Butte plant that I was just mentioning. And then starting next year, Babbitt Ranches wants to put in an additional 480 megawatts of photovoltaic power just north of the peaks. That means we will have, in just a couple of years, a total of 1,424 megawatts of clean electricity right in our region around Flagstaff. So when is it the time to start electrifying our homes and our transportation? The time is now, because the clean energy is largely here and is a lot more is on the way. This is being done all over the world. This happens to be the Perrin Ranch wind power plant out near Williams, with our mountain in the background there for those folks who know this region. And what we need to figure out is how to store that photovoltaic and wind power when, we store it at a time when there's maximum production, for those times like at night when there's no photovoltaic power production, or when the wind isn't blowing and there's no wind power production. There are lots of different ways to store it. Batteries are certainly one way, and people have been exploring how to do that. But hydrogen is another way. You can use that extra electricity to hydrolyze water into hydrogen and oxygen gas, and then use that hydrogen gas as an energy source for fuel cell-based applications, including cars. And I think one of the main ones that will be needed is for long-haul trucks. You cannot have a big enough battery for long-haul trucks because it weighs too much, but hydrogen doesn't. And so you can use hydrogen for those kinds of applications where batteries don't work. Pumped water storage is another way to store that energy. When you've got excess electricity, you pump water to a higher elevation, and then you use hydropower from that elevated water to produce electricity when you need it. This is just an example of a pumped hydropower storage in Ludington, Michigan. Do we have the potential for that here in Arizona? Yes. If you look ringing around Phoenix, there are all kinds of reservoirs and other places to store pumped water that can then be used to generate electricity using hydropower technology when you need it. So we do have the potential to do that here in Arizona in a pretty big way. Another good application is this solar thermal electricity production. This is the Solana plant that APS put in down around Gila Bend. It is a 480 megawatt power plant, which they estimated is enough power for about 80,000 homes. And the way this works is, these are actually troughs, mirror troughs. And in the focal point of those troughs is a tube, vacuum sealed tube of oil that absorbs the heat energy. The heat energy is taken to these large vats here in the middle. These are vats of molten salt, which is a really good way to store heat. So you take that heat that's stored during the day from all of these parabolic mirror troughs, and you can use that heat during the night to generate steam and thereby generate electricity. So these kinds of technologies at a large scale can help us. They're already being, this has been in place for quite a few years already down at Gila Bend, and so it's been tested out. It works and can be applied more broadly. This is what I was mentioning before, the energy efficient design for cities that was put together by architect Paolo Soleri and has been tested for years at Arcosanti, just to the south of us here in Flagstaff. The idea here is to have these aprons which have terraced agriculture as a way to collect heat energy to heat the city and generate food to feed the city. It turns out they've been testing this at Arcosanti for a number of years. And what they're finding is that the heat needed to heat the city is too much for growing plants. So they're now testing ways to have a couple of layers of plexiglass that would allow them to divert some of that heat so they can still grow food, at least in certain seasons, and heat the city in others. There are many different aspects of passive solar design in this city. This version of the city is put together for China. And the idea is to build this along waterways and other transportation corridors and so forth, so that you can have the city compactly built like this with relatively less impact on the landscape, which can then be used for agricultural purposes, for natural habitats, or protected from the impacts of that human development. This is just another schematic of that, what they call the lean linear city. It uses a lot of passive solar type of principles that I'm sure you all have seen before, where you design your building or home in such a way that when the sun is high in the zenith during the summer, that solar energy is less of that solar energy enters the home because you've got awnings. And when the sun is low on the horizon during the winter, more of that solar energy comes into the home when you want that heat. This is one that I think we're maybe a little bit less familiar with. How many of y'all have been to the Zion National Park Visitor Center? It has this passive downdraft cooling system. And basically what you got is some evaporative cooling pads. The air in this column is colder, and so it drops because cold air is heavier than warm air. And so without a fan, this cools the building because of that downdraft of cold air. This is not new technology. It's just that we haven't familiarized ourselves with it in the last few generations. But this ancient mosque uses that design, and this Toguna building in Mali uses that kind of design of downdraft cooled air. So there are better ways to build our buildings than what we've been doing recently, and we need to refamiliarize ourselves with them and implement them. Electric and hydrogen cars are being produced here in Arizona, so we don't need to go far. Phoenix Motor Cars has been producing medium-duty trucks since 2019. These are all electric. Lucid Motors, also here in Arizona, has been producing electric cars, including Lucid Air, this particular model of electric car that has the potential. It has a range of 500 miles. Nikola Motors has been producing hydrogen trucks, including those long haul trucks we were talking about earlier. But they also produce a pickup called the Badger, which is both electric and hydrogen. And between the battery storage and the hydrogen storage, this truck can go 600 miles. So there are lots of different companies that are working on better technologies that we should be able to implement in the near future. Again, if we are going to transition society, all of society, away from fossil fuels, we've got to pay attention to these United Nations Sustainable Development Goals so that people don't fall through the cracks as this huge shift is made. It's going to require attention to folks who are economically unable to go through that transition and help them. And all of this education will be needed to help people shift to new jobs. And there's all kinds of different components we need to pay attention to if we're going to do this transition without leaving people behind and keeping them from being able to feed their families, in which case they're more likely to reach for revolution. So we need to pay attention to these goals if we're going to transition society at large in such a huge and rapid way. Cement production we haven't really talked about, but cement production is another way in which we affect CO2 in the atmosphere. The production of clinker, when you're producing the cement itself, initially releases a lot of CO2, and then the curing of that cement is another place where it's released. There are now companies who are looking at ways to reduce this total amount of CO2 released from cement production. And biomason is one of those. They use bacteria, and that type of cement replacement absorbs CO2 from the atmosphere. So it's actually, rather than being a source of CO2, it's a sink of CO2. And here's an example of one of their products. They can make a brick like this and sell you that brick. But they're now working also on formable varieties of this cement replacement so that you could pour it into a form. It does its thing and solidifies, absorbing CO2 along the way. And so you can use it in a way that's similar to the way that cement is currently used. One other thing that people have explored that would potentially reduce the Earth's average temperature is the release of aerosols into the atmosphere. Those aerosols are, we know their kind of function because they're released when volcanic eruption happens. And it does block incoming sunlight, reflecting more of it back into outer space. And so it has the potential to reduce the Earth's average temperature. But I'm worried about this solution. I think it's maybe good to test some of these ideas out. One of those aerosols that they consider using is sulfate. And we know the effect of that because that would result in more intense acid rain. So I think that's a particular route we don't want to use. But there are other aerosols that we could use. But my question still is, how does this affect photosynthesis? How would this affect the productivity of our agricultural ecosystems and our natural ecosystems? So we need to really test this carefully. The good thing is that the aerosols don't stay in the atmosphere for very long, so we can do some testing of this concept without having long-term effects on our atmosphere and productivity of the Earth's ecosystems. So that might or might not be one of the things we consider. But if we don't rein in our emissions, this is the projection, same type of graph I showed you earlier for 1850 to 2016, but now projected out to 2100. What will happen to the Earth's average temperature if we don't rein in our emissions? Well, but this particular projection says that by the year 2100, we will have raised the Earth's average temperature by about 5 centigrade degrees. And we're just beginning to understand all the effects that that would have on our climate, our agricultural productivity, and humans' ability to just survive. You get those kinds of temperatures under high humidity conditions, and people will die as a direct result of that heat. So if you are in Northern Arizona, please join us and join others in this fight to reduce our emissions. You can learn more about NASCA at our website. You can sign up to volunteer. There are several links specifically to join different climate action teams or just to join overall. If you sign your name, we will reach out to you and see what ways you would like to get involved and inform, engage, and empower you to do something about climate change. If you have any questions beyond what we'll ask today, you can always reach out to me at my NAU email address. And I encourage you all to please get involved. And I'll stop sharing this screen. And I want you all to get involved so that we don't end up with an Earth that looks like this. Thank you all for being part of today. And please do join in NASCA. If you're not located in Northern Arizona, please find your local climate education and activist group and join them. Thank you all for being here.
Thank you, Dr. Sommer. That was really informative. And several of us are hoping that the slides can become available, as well as the presentation. I don't think we've talked about that before, but I think I would like to have access to some of those slides, and other people said they would as well.
I would be happy to. So
thank you. Super informative.
If you would like the slides, I'm happy to share them. I want to empower you to also become a climate ambassador in the strongest possible way. So I'm happy to share these slides. Please send me an email and we'll figure out a way. My problem is that the PowerPoints are so huge that I cannot attach them to an email. So we'll have to figure out some Google Drive way to get them shared. But reach out to me and we'll figure out a way to get the slides to you.
Thank you. And we have lots of questions and conversation in the chat. So let's see here. This was mentioned earlier on, but would you talk a little bit more about why Flagstaff would not divest from Wells Fargo and why that campaign has been challenging?
Well, so yeah, I was at a lot of those city council meetings where the climate action team, Fossil Free Arizona, presented to city council and urged them to do what some of the other cities in the United States have done and find clean banks to invest and manage their money. The city treasurer stood up and spoke for 45 minutes in front of city council about all the benefits that he gets by interacting with Wells Fargo. Many of the things he said in that 45 minutes were repetitions of things he had said in other ways during that time. So it was repeats of the same information over and over. But also, I tried to point out that any of the large banks, even the clean ones, would provide the same services. Yes, you'd have to do some work to transition to this new bank and get them all understanding your system. But for Christ's sake, you got to do this. You got to take that time. City council listened to the treasurer and were completely swayed that they should not even put out, it was the time year-wise that they could have put out requests for proposals to other clean banks. But the city council unanimously stuck with what the treasurer was advising and voted against even putting out a request for proposals. Now, and we know some of these city council members understand the problem of climate change, and still they would not even put out a request for proposals. So I think in this next election cycle, we need to replace these city council members. That's really the only option we have left. this decision with Wells Fargo to stick with a dirty bank that abuses its customers and has been spending tens of millions of dollars per year in fines because of its abuse of its customers. They would not divest from that company. And it's just unconscionable. And now they've approved this $1 billion development proposal without even understanding what its carbon footprint would be. So they had no way to assess just how badly it would affect the ability of the city to reach net zero by 2030. So we've tried and tried to reach the city council, and we will continue to try to reach them. But on these two massive carbon footprint questions, they voted in the wrong direction.
Yeah, yeah, which speaks to why a climate action plan is the first step, but not the last step.
Exactly. Yeah.
So our friend David Spence has posed several questions here. So take note here. The first is, what did Tajikistan do to make it to the top of the list? And then there's two other different questions. One is about Blocklight, and is our local company Blocklight using the biomason technology? And then third, a question about, hold on, I'm finding, oh, hold is it up here? Biocar in restoring carbon into the soil. And what's the potential for making biochar?
Yeah.
And what's the potential for making biochar in northern Arizona?
Oof, all big questions and good questions, Dr. Spence. Thank you very much. Unfortunately, I don't know the details in Tajikistan, but I think in part it might have been the availability of fossil fuels and the availability of renewable energy as they were building their society into having more energy. Some of the third world countries are just now coming up to the point of building their energy infrastructure. And I think Tajikistan was building it at the time when wind and photovoltaic had already become less expensive. That would be my best guess, but I don't really know the situation in Tajikistan. What was the second question?
Blocklight.
Oh, yeah. So there is a company in town here that is producing a cement substitute that has a much lower carbon footprint. It's not the biomason technology, so it doesn't have a negative carbon footprint, but it does have a better carbon footprint than your typical cement does. And so it's a step in the right direction. It's a big step in the right direction. And we were pushing this developer of the $1 billion development to use Blocklight, and they agreed that they would use that to lower their carbon footprint a little. So that was a good thing, but not enough. And the third question was about biochar, I believe.
Biochar, exactly. Which now I know how to pronounce.
Biochar, and it's biochar because you take biological material to produce a charcoal-like substance. And usually when they talk about biochar, they're not really talking primarily about putting it in the soil. They're talking about using it then as a secondary energy source. And so there is a potential for using it as an energy source, probably to get its soil sequestered. You would want to transport it to a more agriculturally active location. And I don't know, you would need to transport it with a clean transportation unless you wanted a big footprint associated with that. One of our NASCA colleagues, Marco Alatorre, has joined a company that is taking forest products, logs, branches, and so forth, and they are burying them in a way that it won't degrade for a significantly long period of time. And the company he's investing in has a name. We are going to ask him to be one of the presenters in this series so he can tell us in more detail about that. But they've already made their first deposit of forest products. And I don't know if they'll be monitoring it for carbon release or, what the long-term aspect there is, but Marco can tell us all the details when he presents later in this series. There's some potential. You would be taking biologically stored carbon and storing it for a longer period of time by burying it under certain conditions. That's the idea behind it. What is it? It's called wood deposit or carbon deposit, something along those lines. There's some potential if you store it for long enough, and it uses biological organisms to sequester that carbon. So that's a good thing as well. And it also potentially is a way to fund forest thinning. And because our forests are drying out and now beginning to die, as we discussed in the last presentation, we need to figure out ways to not only thin our forests, but get an economic return from that thinning of the forest, and a way to use the results of that thinning to store carbon away from the atmosphere. So, it does address some of the things we need. Marco understands the overall carbon footprint aspect of it better than I do, so I'll defer to Marco when he presents in the series, as I will for Dr. Spence. So Dr. Spence will also be one of our presenters later in the series, talking about hydrogen and the potential for hydrogen for not just long-haul trucking, but maybe other applications as well. And Dr. Murray, who's with us, will also be one of our presenters. And I believe it's on September 23rd, when he'll be talking about the overall climate system and how it's impacted by human activities and how that affects natural ecosystems and other things. I believe. I might be saying that wrong, so correct me, Greg, if Dr. Murray.
Mostly it's about the origins of the climate system of our planet from first principles. So the size and shape of the Earth, its orientation in the solar system, but composition of the atmosphere, but then how climate influences the distribution of and abundance of living things.
Very good.
So not about climate change per se, although that comes up in several places, and we can discuss that at the end too. But it's really about the origins of climate.
Very good. And Dr. Reamer, I should point out, will also be one of our future speakers. So people in different societies and people of the two genders, the various genders, are affected differently by climate change, and she'll be helping us to understand some of the details of how climate change disproportionately affects different populations.
Exactly. So we have two questions that take us in interesting directions. One is if you have any updates on Arizona's solar and rates that are related to solar. And then a second is around technologies that rely on water. And is that a smart idea to be reliant on water reliant to build more water reliant energy infrastructure in a place where water is, of course, in high demand?
Yes, so we did talk a little bit about the solar that's already going on and being installed in northern Arizona. Babbitt Ranches is putting in 408, as we speak, they're putting in 80 megawatts of photovoltaic just north of the peaks. And starting next year, they're going to be putting in another 480 megawatts of photovoltaic. The Solana plant down at Gila Bend also is a form, it's not photovoltaic, but it's solar energy, solar thermal energy specifically. So we have a huge potential for solar energy in the state of Arizona, more than a lot of states that produce more solar energy than we do. We should be using that potential to its fullest. And we're not doing that yet, but we've tested it out enough that we know enough of how to best use that solar energy.
What about
Yeah,
what,
yeah,
what
yeah,
about rooftop solar, which
yeah,
we're
rooftop.
interested in? That's why I came to Northern Arizona Climate Change. I can't afford rooftop solar in my house, which seems absurd to me. John, you were posing that
Yeah,
question.
that's the big fight we're having in California is the CPUC, Public Utility Commission. Basically, they got a new rate structure that economically discourages rooftop solar by individuals. It's almost like they want to monopolize it. And so that's been a big fight we've had. And I understand from people I know in Arizona, it's something similar there as well. And then there's things like charging people to go, if you go off grid, the utility charges you for going off grid, and et cetera. So
It's an excellent question, and I'm not necessarily the best expert to answer it, but I do know certain things. So, yes, the utilities try to discourage home photovoltaic solar producers, and they've done that by changing the rate of return for that home produced electricity. And it's the Arizona Corporation Commission who regulates how all of that operates. So we've been working hard to get the right people elected, because those are elected positions on the Arizona Corporation Commission. And we do have a couple of folks with the right mindset in those positions. But also, one of the things that happened was we've got our primary utility is Arizona Public Service, but we also have the Snake River Project as another major utility, and they produce a lot of the hydroelectric power in the state. They were charging higher rates for the electricity produced by home solar producers. They got taken to court for that behavior, and they lost in court. So they now can no longer do that. You know, it's always one little battle or another. Well, I call them little, big battle after another. And we have to keep fighting them. So we keep lobbying the Arizona Corporation Commission to do the right thing on those rates, because really, the utilities should be encouraging rather than discouraging that home production. We know that for quite a few years now, the cheapest ways to produce electricity are wind and solar, photovoltaic solar. It costs significantly less to produce electricity that way than generating it with any kind of fossil fuel. And I didn't include those slides this time just because I could bring those slides up if y'all want to see them. I took them out of the presentation just because of lack of time. But it's not only cheaper than any kind of fossil fuel generation of electricity, but it's way cheaper than any kind of nuclear generation of electricity. So,
And
Arizona Public Service has told folks that if we put in more photovoltaic or more renewable energy sources, that your electricity rates will go up. They're saying that because it's misinformation. I mean, it's much cheaper to generate the other way, but I suppose they would have a higher cost because they would have to install that infrastructure. So there might be temporary increases, but overall it's cheaper for them to produce electricity that way.
And Donna has mentioned in the chat that the utility in Montana is acting similarly.
Well, congratulations for being from Montana. That's where the kids recently won a major lawsuit against the fossil fuel industry, which will set precedents for years to come. Thank you, Montana. So help me understand your question, Donna. Go ahead and unmute.
Or tell us something about the Montana utility situation.
Yeah.
Oh, I didn't actually have a question, but the reason they are against it is because of the way the rate structure is built. They make more money off of fossil fuel because they will build infrastructure and then they will be able to charge the customer for infrastructure that they've installed. Whereas if I install the infrastructure on my roof, they don't get to charge other customers for that infrastructure. So the way it's set up, they make more money if they build a new gas-fired plant out at Laurel, which they're trying to do. We're fighting it, but we don't know which way the wind is going to go. Hopefully, the precedent set by Held versus Montana might give them pause. Cross fingers.
Well, yeah, so that was my question was going to be that. How did that lawsuit outcome affect this particular situation of the new fossil fuel plant?
We have yet to see, but it gives us hope, right?
Absolutely, yeah. So yeah, the state of Montana gets a lot of tax support through fossil fuels. I think Wyoming doesn't charge any state tax because the fossil fuel industry covers what they need. Am I misremembering that?
And we have a large geographic participation today. So Laura's iPad is in Florida, has said that this is interesting. We see collusion from insurance companies that won't insure homes with solar on roofs unless the roof is new.
Wow. That's crazy. Okay, so yeah, there are various ways that the utilities have found to discourage home photovoltaic applications. They have been called on the carpet in various cases for their higher rates that they charge and other ways. But to be on the other side, to be fair, the utilities have put money into the big distribution system required to distribute that electricity. And so they do, I think, have a right to charge for that. But how much they charge, they've been way exaggerating what that cost is and putting a much larger load on the home producers than they should. And that's where a lot of our battles with our Arizona Corporation Commission have been, is just how much can they reasonably charge for that infrastructure. It should be some, but it shouldn't be what they've been charging recently.
Yeah. And you mentioned, of course, we know NASCA is not partisan, but you mentioned the Arizona Corporation Commission, and that is certainly a place where our votes matter and has been a place that's been really sort of entrenched.
Yeah.
So,
yeah. And the decisions they make have a big effect on the ease of installing home, not just photovoltaic, but home wind or any kind of home energy production. And overall, I said it a few times during the presentation, but overall, the biggest thing we need to do is reduce our consumption. If you do go off the grid, you are under significant pressure to buy more energy efficient appliances, more energy efficient transportation, and all of those things. And it becomes part of your daily consciousness if you get off the grid. And we need to follow the same reasoning, even if we're on the grid.
So we do have a positive update here from Dr. Murray about Prescott and the Quad Cities and their climate action. plans. Dr. Marie, did you want to say anything about that? That seems like a really positive note. I know we've been working south of Sedona to increase participation.
Sure. Yeah, I put that in the chat. And so the slide was dated 2021, and there has been action since then. As you know, every 10 years, every Arizona municipality has to update its general plan, and we and I've only lived here for 2.5 years now, but a group here has been working to essentially lobby the Prescott City Council to commission a climate profile or a climate risk assessment for some time. That was called the Protect campaign, and that was successful. And last May, the City Council in Prescott commissioned that that study from the Klimas group at the University of Arizona, and they approved it unanimously, largely because Klimas offered to do it for free. I think several other Arizona communities had to pay, $50,000 or $100,000 for theirs, but I guess Klimas had some money left over at the end of a funding period, and they did ours for free. That was accepted back in February, and a working group of some of the people from nonprofits here and government people from the county and municipal level and stuff like that got together and put together a list of climate adaptation suggestions, essentially, in a companion document, and presented that to City Council at the same time. And since then, we've been meeting with other groups and with City Council people and with the General Plan Committee that is well into its work now to get some of those suggestions included in the next general plan for the city of Prescott. We've been meeting also with the Quad Cities Climate Collaborative. Actually, the Quad Cities refers to Prescott, Prescott Valley, Chino Valley, and Dewey Humboldt. And so most of the activity is here in Prescott, but we've also been meeting with some folks in Prescott Valley. And Prescott recently contracted with Schneider Electric to do a municipal energy audit of all of their operations. Prescott Valley already did that last year and is already implementing some of those things and saving millions of dollars and decreasing their carbon footprint. So it's slower here than in some places, but there is action taking place even in hyper-conservative Prescott.
Step by step. I mean, those are all positive movements. So
Absolutely. And so oftentimes the economic arguments are the strongest because they come across the aisle more easily.
That's very much the case. And so one of our strategies has been to look for what we're calling the low-hanging fruit, the things that sort of meet the triple bottom line of sustainability and sort of highlighting the economic benefits of doing that because they're not that hard to sell. And one of the things is increasing the efficiency of municipal buildings because you start to get the savings right away. And also for here, even though this is a little bit harder to do, but increasing the availability of EV charging infrastructure. In a town like Prescott, where the downtown is very much dependent on tourism, recruiting the support of downtown merchants to essentially put charging stations in places that will essentially capture tourists that have to stay there for a little while their cars are charging. That's a win-win for everybody.
Absolutely. Yeah, that's where we're getting some of our charging infrastructure in Flagstaff as well. But fortunately, also the Inflation Reduction Act has provided money for charging stations at like 50-mile intervals along interstates, and we are working with the county because they are particularly concerned about the charging station being such a large county.
Mm.
So how do we get, if we buy electric vehicles, how do we get them all the way out to wherever?
We're just about at time, but I don't know if anyone has one. We're so small that if someone has a question, we're small enough that if someone has a question, one.
Please unmute and
Yes.
make it a discussion. So John, out of curiosity, are you with the North County Climate Change Alliance?
Yeah. I'm involved in Sierra Club, Solana Beach Eco Rotary. Yeah. So we've got various groups and we have climate action plans, most of the North Coastal cities. So we're on a certain amount of this anyway.
Very good. So I consider the North County Climate Change Alliance to be our sister organization in the sense that Rolf vom Dorp helped to get you guys going and was one of our founding members, our primary founder really for NASCA. All right. Well, thank you all again for coming, and thank you all for the good work that you're doing in each of your communities. Let's empower one another as we empower our community members to be as effective as possible in fighting this global disaster.
And thank you, Dr. Sommer, for your really enlightening presentation.
Thank you. All right. Well, carry on. Do good
I'll
work.
see you again